Chapter 11 Wrap-up. In this chapter, you learned how to overload operators to work with class objects. We demonstrated standard C++ class string, which makes extensive use of overloaded operators to create a robust, reusable class that can replace C-style, pointer-based strings. Next, we discussed several restrictions that the C++ standard places on overloaded operators. We then presented a phone number class that overloaded operators, and to conveniently output and input phone numbers. You also saw a date class that overloaded the prefix and postfix increment, ++ operators, and we showed a special syntax that's required to differentiate between the prefix and postfix versions of the increment, ++ operator.
Next, we introduced the concept of dynamic memory management. You learned that you can create and destroy objects dynamically with the new and delete operators, respectively. Then, we presented a capstone array class case study that used overloaded operators and other capabilities to solve various problems with pointer-based arrays. This case study helped you truly understand what classes and object technology are all about, crafting, using, and reusing valuable classes. As part of this class, you saw overloaded stream insertion, stream extraction, assignment, equality, relational, and subscript operators.
You learned reasons for implementing overloaded operators as member functions or as non-member functions. The chapter concluded with discussions of converting between types, including class types, problems with certain implicit conversions defined by single argument constructors, and how to prevent those problems by using explicit constructors. In the next chapter, we continue our discussion of classes by introducing a form of software reuse called inheritance. We'll see that when classes share common attributes and behaviors, it's possible to define those attributes and behaviors in a common base class and inherit those capabilities into new class definitions, enabling you to create the new classes with a minimal amount of code. Summary. Section 11.1 Introduction. C++ enables you to overload most operators to be sensitive to the context in which they reused. The compiler generates the appropriate code based on the types of the operands. One example of an overloaded operator built into C++ is operator, which is used both as the stream insertion operator and as the bitwise left shift operator. Similarly, is also overloaded. It's used both as the stream extraction operator and as the bitwise right shift operator. Both of these operators are overloaded in the C++ standard library. C++ overloads plus and minus to perform differently, depending on their context in integer arithmetic, floating point arithmetic, and pointer arithmetic. The jobs performed by overloaded operators can also be performed by explicit function calls, but operator notation is often more natural. Section 11.2 Using the overloaded operators of standard library class string. Standard class string is defined in header and belongs to namespace std. Class string provides many overloaded operators, including equality, relational, assignment, addition assignment, for concatenation, and subscript operators. Class string provides member function empty, which returns true if the string is empty, otherwise, it returns false. Standard class string member function subster, page 455, obtains a substring of a length specified by the second argument, starting at the position specified by the first argument. When the second argument is not specified, subster returns the remainder of the string on which it's called. Class strings overloaded operator does not perform any bounds checking. Therefore, you must ensure that operations using standard class strings overloaded operator do not accidentally manipulate elements outside the bounds of the string. Standard class string provides bounds checking with member function at page 456, which throws an exception if its argument is an invalid subscript. By default, this causes the program to terminate. If the subscript is valid, function at returns a reference or a const reference to the character at the specified location depending on the context. Section 11.3 Fundamentals of operator overloading. An operator is overloaded by writing a non-static member function definition or non-member function definition in which the function name is the keyword operator followed by the symbol for the operator being overloaded. When operators are overloaded as member functions, they must be non-static because they must be called on an object of the class and operate on that object. To use an operator on class objects, that operator must be overloaded, with three exceptions: the assignment operator, equal sign, the address operator, and the comma operator, comma. You cannot change the precedence and associativity of an operator by overloading. You cannot change the arity of an operator, i.e., the number of operands an operator takes. You cannot create new operators, only existing operators can be overloaded. You cannot change the meaning of how an operator works on objects of fundamental types. Overloading an assignment operator and an addition operator for a class does not imply that the plus equals operator is also overloaded. Such behavior can be achieved only by explicitly overloading operator plus equals for that class. Overloaded, dash, and assignment operators must be declared as class members. For the other operators, the operator overloading functions can be class members or non-member functions. Section 11.4 Overloading binary operators. A binary operator can be overloaded as a non-static member function with one argument or as a non-member function with two arguments. One of those arguments must be either a class object or a reference to a class object. Section 11.5 Overloading the binary stream insertion and stream extraction operators. The overloaded stream insertion operator is used in an expression in which the left operand has type OStream and. For this reason, it must be overloaded as a non-member function. To be a member function, operator would have to be a member of the OStream class, but this is not possible, since we are not allowed to modify C++ standard library classes. Similarly, the overloaded stream extraction operator must be a non-member function. Another reason to choose a non-member function to overload an operator is to enable the operator to be commutative. When used with SYN, setl restricts the number of characters read to the number of characters specified by its argument. iStream member function ignore discards the specified number of characters in the input stream, one character by default. Overloaded input and output operators are declared as friends if they need to access non-public class members directly for performance reasons. Section 11.6 Overloading unary operators. A unary operator for a class can be overloaded as a non-static member function with no arguments or as a non-member function with one argument. That argument must be either an object of the class or a reference to an object of the class. Member functions that implement overloaded operators must be non-static so that they can access the non-static data in each object of the class. Section 11.7 Overloading the unary prefix and postfix and operators. The prefix and postfix increment and decrement operators can all be overloaded. To overload the pre- and post-increment operators, each overloaded operator function must have a distinct signature. The prefix versions are overloaded like any other unary operator. The postfix increment operator's unique signature is accomplished by providing a second argument, which must be of type int. This argument is not supplied in the client code. It's used implicitly by the compiler to distinguish between the prefix and postfix versions of the increment operator. The same syntax is used to differentiate between the prefix and postfix decrement operator functions. Section 11.9 Dynamic memory management. Dynamic memory management, page 469, enables you to control the allocation and deallocation of memory in a program for any built-in or user-defined type. The free store, sometimes called the heap, page 469, is a region of memory assigned to each program for storing objects dynamically allocated at execution time. The new operator, page 469, allocates storage of the proper size for an object, runs the object's constructor and returns a pointer of the correct type. The new operator can be used to dynamically allocate, page 469, any fundamental type, such as int or double, or class type. If new is unable to find space in memory for the object, it indicates that an error occurred by throwing an exception. This usually causes the program to terminate immediately, unless the exception is handled. To destroy a dynamically allocated object and free its space, use the delete operator, page 469. An array of objects can be allocated dynamically with new as in int *ptr equals new int 100. Which allocates an array of 100 integers and assigns the starting location of the array to ptr. The preceding array of integers is deleted, page 469, with the statement delete ptr. Section 11.10 Case study, array class. A copy constructor initializes a new object of a class by copying the members of an existing one. Classes that contain dynamically allocated memory typically provide a copy constructor, a destructor, and an overloaded assignment operator. The implementation of member function operator equals should test for self-assignment, page 481, in which an object is being assigned to itself. The compiler calls the const version of operator when the subscript operator is used on a const object and calls the non-const version of the operator when it's used on a non-const object. The array subscript operator can be used to select elements from other types of containers. Also, with overloading, the index values no longer need to be integers. Section 11.11 Operators as member functions versus non-member functions. Operator functions can be member functions or non-member functions. Non-member functions are often made friends for performance reasons. Member functions use the this pointer implicitly to obtain one of their class object arguments, the left operand for binary operators. Arguments for both operands of a binary operator must be explicitly listed in a non-member function call. When an operator function is implemented as a member function, the leftmost, or only, operand must be an object, or a reference to an object, of the operator's class. If the left operand must be an object of a different class or a fundamental type, this operator function must be implemented as a non-member function. A non-member operator function can be made a friend of a class if that function must access private or protected members of that class directly. Section 11.12 Converting between types. The compiler cannot know in advance how to convert among user-defined types, and between user-defined types and fundamental types, so you must specify how to do this. Such conversions can be performed with conversion constructors, page 484, single-argument constructors, page 484, that turn objects of other types, including fundamental types, into objects of a particular class. Any single-argument constructor can be thought of as a conversion constructor. A conversion operator, page 484, must be a non-static member function. Overloaded carstopper, ATA functions, page 484, can be defined for converting objects of user-defined types into fundamental types or into objects of other user-defined types. An overloaded cast operator function does not specify a return type. The return type is the type to which the object is being converted. When necessary, the compiler can call cast operators and conversion constructors implicitly to create temporary objects. Section 11.13 Explicit constructors. C++ provides the keyword explicit, page 486, to suppress implicit conversions via conversion constructors when such conversions should not be allowed. A constructor that's declared explicit cannot be used in an implicit conversion. Section 11.14 Building a string class. Overloading the function call operator, page 487, is powerful, because functions can take an arbitrary number of parameters.